Okay, so the switch in this circuit is closed at t equal to 0 after being open for a long time. Okay, so before t equal to 0, so when t less than 0 for a long time, the switch has been open. So basically that's open. And in that case also, the capacitor will be charged and it's going to be open. So the equivalent circuit before 0 is this. So we have 1, 2, 1, 2, 3, 3. So as you see, I opened the capacitor and the switch was also open. So this is our circuit. And the problem wants us to find I1 at 0 negative and I2 at 0 negative. So this is I1 and this is I2. Okay. So in this case, okay, so it's a circuit, simple circuit. We want to find these currents. We can do either mesh analysis or node voltage analysis. So let me do the mesh, but it doesn't matter. We can do also node analysis. So because this is a current source, 100 milliamp, so I consider the mesh current here 100 milliamp, and let's assume current I for this loop. So we write the equation. So start from here. Write it here, minus 1 going here, plus 20 times the I minus the current is going that way, 100 milli. Then continuing plus. So all these resistors are in series 5 and 2, 7 and 3, 10. 10 times the current, which is I. Equal to 0. Okay, so just one variable, 20I and 10I, 30I. And then minus 2000 and then 10 to the power minus 3, which is 2, equal to 1. In other words, 30I equal to 3, and I is 0.1 amp. So I is 0.1 amp. In other words, and as you see, I1 and I2 are exactly equal to I. Okay, so therefore I can say I1 at 0 negative equal to I2 at 0 minus, and both of them equal to 0.1 amp. So that answers part A. Now it says find I1 at 0 plus and I2 at 0 plus. So basically at t equal to 0, we close the switch and we want to find now the current just right after the switch. So I would write t equal to 0 plus. So how will be the circuit? So we have the 20 ohm. We have our voltage source. We have the current source. Oh, oops. So after you quit, you close this. Okay, so the whole thing will be short circuit. So I'll get back to that. So there's a 5 ohm. There is a 2 ohm. There is a 3 ohm. And there is a capacitor, which is charged by what is the voltage of that? Okay, so let's calculate that. So what is this voltage at just before the before we close the switch? So if I call this V1 T, V1 at 0 negative is this voltage, which is exactly voltage also across these 2 ohms. So it is 2 times I1 at 0 negative. So 2 times 0.1, 0.2 volts. Okay, very good. So the capacitor is charged by 0.2 volts. So I will put the 0.2 volt here. Because right after we close the switch, this is gonna be the voltage across capacitor. In other words, V1 at 0 plus is also equal to V1 at 0 minus equal to 0.2 volt. And this is because the capacitor cannot, the voltage across the capacitor cannot change suddenly. So it keeps the voltage somehow. So we have this initial condition for this capacitor. But also interestingly here, because we close the switch, so this is short circuited. So basically all this part of the circuit is somehow, doesn't matter anymore, it's shorted. So therefore we can just remove this part and just look at the other side of the circuit. Okay, again, this is because it was the left side is just shorted. So the voltage across that is 0. And so basically we are left with this circuit, this small circuit here. And I want to find, again, going back to I1 and I2 at this time. Okay. So I1 is clear here, as you see, because again, the voltage V1, this is, we have the voltage, and then I can find the I. So I1 at 0 plus is V1 at 0 plus divided by 2, which is 0.2 divided by 2, 0.1. This is I1. How about I2? To find I2, we can do a KVL. So to find I2 at 0 plus, let's do a KVL. So 5 times I2, 5 times I2, and then the voltage here is the voltage, so plus 0.2 volts, and then plus 3 times. So I2 is coming here, and then it's still I2 also, because they're connected, right? This is the I2. So 3 times I2 equal to 0. So 8 I2 equals to negative 0.2. I2 equals to negative 0.2 divided by 8. Negative 0.2 divided by 8. Then let me be correct. This is now I2 at 0 plus. Okay. And this answers the part B of the question that we wanted to find I1 and I2 at 0 plus. So we got I1 and I2 at 0 plus. So now, next part is asking for now I1 T and I2 T after the switch. So now looking at the whole current and voltage across time after the switch is closed. So in other words, for T greater than or equal to 0, what is I1 T and I2? Okay. So as we look at the circuit, again, the circuit in the yellow box, and this is a natural response of it. It's the RC circuit, first of all, and we are looking for a natural response because there's no other source. So therefore, I only need to look at I1, let's say, for example, at 0 plus, or if I want to find I2 at 0 plus, so initial condition, and then also I need to know the time constant, which is R equivalent times C. So I need to find these. So let's go from there. Or we can also say, okay, we go with the general formula. For general formula, okay, I need the initial condition and also I need the final. Let's say current I1 at infinity and I2 at infinity. But looking at it, because there's no current source, then the I1 at infinity would be 0, I2 at infinity also would be 0. Okay, so at infinity, the capacitor will be open and there's no other, like, there's no voltage source or current source basically. So those two values gonna be 0. So it really doesn't matter which formula you use, or you go with the natural response or the general response. So therefore, I put a note here that also note that I2 at infinity is 0, I1 at infinity also is 0. Again, this is because there's no source. And we are just doing the natural response. Okay, very good. So, but still we need to find the time constant. C times R equivalent. Okay, so I have C, but I need to also look at the R equivalent from the point of view of C. So this is two terminal. So what is the R equivalent that C? So as you can see, 5 and 3 are in series, and they are in parallel with 2. So in order to see it better, so this is my C. There was a 2O here. There was a 5O and a 3O, right? So these two are in series. So 5 plus 3 is 8 ohm. And that 8 ohm is in parallel with 2. So therefore, our equivalent is 8 parallel with 2, which is 8 times 2 divided by 8 plus 2, 1.6 ohm. This is what the capacitor is. R equivalent, and then time constant tau equal to R equivalent 16 times capacitance, which is 2 micro. Is 32 micro second. So accordingly, I1 T is I1 at 0 plus, again, natural response, that's E minus T over tau. I1 0 plus is 0.1, E minus T over 32 micro. This is for T equal to 0. And I2 is I2 at 0 plus, E minus 0. What's I2? It's negative 0.2 divided by 8, E minus T over 32 times 10 divided by. Okay, so these are the natural responses. for I1 element.